Welcome to the new video, guys. In this video, we will be covering how does AI actually understand text. When you type a question into ChatGPT or any AI tool, what really happens behind the scenes? Is it reading like a human or doing something completely different? Today, we'll break it down step by step. We will cover tokenization, vector representations, cosine similarity, and embeddings in the simplest way possible. Let's start with the very first step, tokenization. AI models don't read full sentences like we do. They break text into smaller chunks, called tokens. For example, I love AI might get divided into I and love and AI. But sometimes it goes even smaller. Playing might become play and ing. This is done because computers work better with smaller, structured units. Tokenization is like breaking a paragraph into Lego pieces so the model can process it. Let us now discuss about the vector representations. Once text is tokenized, AI converts it into numbers. This process is called creating vector representations or embeddings. Think of it like this. Every word or sentence gets mapped to a list of numbers, like cow will be mapped to 0.2, minus 0.1, and 0.8. And dog will be mapped to 0.25, minus 0.05, and 0.75. These numbers capture meaning. So similar words have similar vectors. Cat and dog are closer than cat and car. You can imagine this as placing words in a 3D space where similar meanings are closer together. Now the question is, how does AI measure similarity? This is where cosine similarity comes in. It calculates how close two vectors are by measuring the angle between them. If the angle is small, then they are similar. If the angle is large, then they are different. For example, what is AI? Explain artificial intelligence. Even though the wording is different, their vectors will be close height cosine similarity. So instead of matching exact words, AI matches meaning. An embedding is a vector whose values are trained to capture meaning, so that similar words or sentences are placed close to each other in space. An example of the vector, which is not an embedding, is being shown on the screen. Let's say this represents height in centimeters, weight in kilograms, and age in years. This is clearly a vector. But is it an embedding? No, because it was not trained to capture meaning. It doesn't represent relationships like similarity between concepts. It's just raw numerical data. It's a vector used for data representation, not semantic understanding. Example of an embedding, and therefore also a vector, is being shown on the screen. Why is this an embedding? These vectors are learned from large text data and are designed so that king is equal to queen, close. However, king is not equal to apple. This captures semantic meaning. So the difference is not in the format, but in the purpose and training. A vector becomes an embedding when it's trained to represent meaning, not just data. That is it for this video. Thank you.